Okay, last time we looked at simple interest. This time we have to talk about compound interest. And compound interest is going to be the one where you're going to make a lot more money because you're getting paid interest on top of the interest you've already earned. So in this lesson, we're going to look at another type of interest. It's compound interest. The interest calculated on the principal amount plus the interest earned, and interest can be paid more than one time per year. Interest is stated as a percentage per annum, that just means per year, and is divided by the number of compounding periods. So that's the number of times interest is paid throughout the year. Underneath, you're going to see four separate cases that you could possibly have. So if you get paid interest semi-annually, it's going to be twice a year, so every 6 months. And what you're going to do is you're going to take the interest rate and divide it by the number of times it's compounded through the year, in this case 2. If it's quarterly, you get paid 4 times a year, so you're going to divide the interest rate by 4. If it's monthly, you get it every month, which means 12 times since there's 12 months in a year. And again, you'll divide the interest rate by 12. Daily means you get interest every single day, so take that interest rate and divide it by 365. Example 1 says, complete the table below to show how an investment of $2,500 will grow over 5 years using compound interest this time. The interest rate is 5%, and it's compounded annually only, so we don't have to divide it since it's only once per year. So the first square in this table is going to be our $2,500 principal amount. The interest rate as a decimal is 0.05. Our interest amount, then, you're going to take the interest rate of 0.05, multiply it by your principal, which is $2,500, very much the same way we did for simple interest. And our closing balance, you're going to add your principal to your interest just like before. So if you remember our chart from last time, the first row is going to be identical. Now our year 2 opening balance is going to be the same thing as our year 1 closing balance. I'm using my new total because I have to get paid interest on top of interest. So my interest is 0.05. If you take 2,625 and multiply it by that interest amount, your new interest amount for year 2 is $131.25. So you can already see the interest amount is larger. And your closing balance will be what you started with, so 2,625 this time, plus 131.25, and you end up closing year 2 with $2,756.25. So if you compare that to your year 2 balance from simple interest, it's going to be larger. And we are going to continue this pattern until we get to the end of the table. $37.81 plus 2756.25, and in total 2894.06. $44.70. And year 5 starting balance is $3,038.76. Your interest rate does not change. Interest earned 151.94. 038.76. And your closing balance after year 5, $3,190.70. So if you look at the interest amount column, you're going to notice that the interest amount being paid increases from year to year. If this was simple interest, that interest amount would stay the same. So of course, every year I'm making money on money I've already earned, and my money's going to grow much, much faster. So those questions under the chart, I started with $2,500. At the end of 5 years, we had $3,190.70. If I want to figure out how much interest I earned, I could take the total amount I ended with, subtract the principal I've put in, 2,500, and when you subtract those values, we've earned $690.70 in interest over the course of 5 years. So a pretty substantial amount of money just for basically doing nothing, putting it into an account. Now, it's going to be really long and tedious to do every single time. So there is a formula for you which will allow you to calculate any given year as long as you have most of the information. So A this time stands for the total amount of money. In simple interest, our formula was I equals PRT, where I was only the interest amount. Okay, this other formula that we're getting, it stands for the total amount of money, so principal including interest. The variable P is exactly the same, just the principal. I is going to stand for the interest rate as a decimal, so convert it first, and then you're going to divide it by the number of compounding periods in a year. So if it's semi-annually, you're going to take that interest rate and divide it by 2. The variable n is the number of times it's compounded, so you're going to take the number of years and multiply by the number of compounding periods. Now I realize that's a lot of words, so it helps to see it using numbers. So there's an example down below. Susan invested $4,000 at a rate of 8% compounded quarterly for 2 years. What is the value of Susan's investment at the end of the 2-year period? Before you can do a thing, we got to start listing out some variables. I'm trying to find the value of her investment, so I'm looking for the total amount. We don't know that one yet. The principal is the amount Susan is investing, and it's going to be $4,000. The interest rate, we're told that it's 8% compounded quarterly for 2 years. So I'm going to take the original 8%, and we have to divide it by the number of compounding periods in 1 year. If it's being compounded quarterly, that means there's 4 times that we're getting paid interest. So take that 8% and divide it by 4. Turn it into a decimal first, 0.08, divide it by 4, and you get 0.02. That's the one we actually need to use in this situation. The only other thing I need is n, which is the number of times the money is being compounded. Okay, so we're doing quarterly for 2 years, which means in 1 year, I have 4 payments. In 2 years, I should have 8 payments. So my number of times compounded is 8 times. We have everything we need. We can put it into our formula given to us for compound interest, and away we go. So here's the formula: principal multiplied by 1 plus that interest rate to the power of n. Principal is 4,000. We have 1 plus 0.02 to the power of 8. Now if we grab our calculator and do all of those nice things, 4,000, 1 plus 0.02 to the power of 8. At the end of this 2-year period, Susan's money will be worth $4,686.64. This is going to be the total value of her investment. Okay, so I'll stop that video there, and the next one we'll do a couple more examples, and we'll get to the practice ones on the bottom.